Okay, now we have to find the equation of the plane, which we know how to do, right? Direction, normal vector, and the point. And we are given 2 points, so we can use either one, right? We'll probably use this one, whichever is nicer. And then perpendicular to this plane. Wow, how do we imagine that? Wow, that's tough now, isn't it? Okay, let's try to figure this thing out one by one. Okay, let's say we have a vector. We have to start somewhere. So let's say we have a vector. Let's say like that. And one end of that vector, let's say this end is -1, 0, 2, because I want to use that point. Numbers are nicer. And the other end happens to be 2, 1, 0. Okay? These are the 2 points. So we got points, and we have a vector. This is far, far from what we want, right? We need a normal vector. Let's say we have a plus. Let me draw the plane. Say this plane looks like this. Okay. Now this thing needs to be perpendicular, right? How the heck are we going to create that? While you think about it, I'll start drawing it. So that second plane with black color will look like this. You know what I'm saying? Yeah, that's a perpendicular plane. This thing really goes inside, but yeah, it's going in and then continues to the other side. How are we going to figure out this normal vector? And I'm gonna move this vector a little bit so that it actually, yeah, that end right there is better. Ideas? I'm gonna move that point a little bit. Okay, the idea is this. What is the normal vector of this black plane? So I'm going to write it down. The equation of this plane is x plus 4y minus 3z is equal to 1, right? And then it should have a normal vector. Let's say that normal vector sticks out in this direction like this, right? So it's perpendicular right there. And this is n. Tell me what that n is.
1 for -2.
1 for -2. Do you all understand -2?
3.
Do you all understand why this normal vector is 1 for -3? That happens to be these coefficients. And do we know why? Okay, that's nice and well. Now we need a normal vector for this red plane, right? I'm going to draw it like this. At that point, the vectors can be moved around, but I'm going to conveniently draw it right there. Good. So this normal vector has to be perpendicular this one as well as this one. You know what I'm saying? Oh, what did I do? Undo. Perpendicular to this one as well. You know what I'm saying? Okay, I'm gonna call this vector, let's say M, because I used N already. Idea on how to calculate M.
Dot product.
Dot product, dotted with what?
Well, with the normal vector and the, I guess.
Oh, this vector, red vector? Let's call that vector A. Okay, what's A?
3, 1, -2.
-2. But then, do you remember if we dot two vectors, then it gives you a scalar, not a vector? So you are thinking about the right thing, but saying the wrong thing. We need a multiplication of vectors that gives you another vector, which is perpendicular to two of these. What was it? Here's a hint.
The cross product.
Cross product, right? We cross these two. Then we get a vector that is perpendicular to both of it. You know what I'm saying? Now, here's an idea. How do we know that this plane, black plane and red plane, are perpendicular? Well, if our normal vectors are perpendicular, then planes are perpendicular. That makes sense to you? Because normal vectors are always perpendicular to the plane itself. So if those two are perpendicular, then planes are perpendicular. So we need to create a vector that is perpendicular to this n and still containing these 2 points. So we use that vector and then we cross it. You know what I'm saying? Okay, so let's cross it. So we do n first. Okay, the ways thrown 1, 4, -3, and 3, 1, -2. Okay. Oh, my computer does that today. So what we have is, for I is this minus this, so -8 plus 3. Is that -5? For J, it's negative vector, so what I do is this minus that, so we have -9 plus 2. Is that -7? And finally, K, 1 minus 12, so -11a. We good? Then our equation of the, somebody tell me what equation of the plane is. Let's use this point. It looks like point slow form. Or should we create a vector and dot it as well? I think we can just do it at this point, right? We have -5x minus what? Plus or minus 7 and y minus 0. I'll just write it. And minus 11 and z minus -3. Z minus 2 needs to be 0. Good. And then I'm going to get 5x plus 7y plus 11z. You want it in standard form or general form? Your choice.
Standard.
Standard form. Hopefully this is not too much algebra for you, right? Questions? Say our origin is here, like that. And then let's say this line just runs through somewhere in space, right? So I'm going to draw that line somewhere in space like that. How about that? So far, so good? Now, what we have to do is, say there's a point that is perpendicular. I'm going to make this thing a little bit bigger, longer, I mean. Say this thing. Whoa, that's nice now, isn't it? There's got to be a perpendicular distance. This is what we mean by distance, isn't it? So far, so good? Okay, let's just figure out any vector, any random vector from the origin here to somewhere on that line. Okay, what is a nice thing to do? What is the very nice point? Somebody give me a brilliant point. What is the coordinate of that point right there? Anyone will do, and we'll call that R naught. Ideas? That line, equation of the line is given to you right here. Let me write it down and see if it makes sense to you. Why did I choose that one? That's when t is equal to 0, isn't it? That's the easiest one to calculate. I mean, you can choose when t is equal to 1, t is equal to anyone will do, right?
Mr. Kim, your screen is frozen from you. Oh wait, it's just very slow. Okay, no.
Oh, that's why, huh? Okay. You get the idea now? Okay, then, now, oh, we have a right triangle, huh? Right, so it's gotta be either sine or cosine, but what is a vector that I can use in this case? This thing has a vector, right? Direction. What is the direction of that vector? I'm gonna draw it right here for the convenience. And that thingy, we call it V. Somebody tell me what V is. If you're flying.
1, -1.
1, -1, 2. You all get why that is the case? You all get the why that is the case? That's the direction, velocity vector, we call it. This thingy, this thingy, this thingy. Now I'm going to make a copy of that vector so that we can see the angle between the vectors. That vector can be slided down here, right? This is exactly same V. And there is your angle, right? So this perpendicular distance D, is that same thing as this distance then? Yeah, it is, isn't it? You see where this is going? So my D here is equal to your R and sine theta, and then absolute value. Too much trick? Too much geometry? Okay. Now, where are you going with this? Well, let me just do this. Is it R? Oh, R, not a vector. R magnitude, R naught magnitude, B sine theta divided by V magnitude, eh? Okay, that numerator, what does that remind you of?
Cross product.
That's a cross product, isn't it? Oh, so all we have to do is just take the cross product. We have R and we have V. Let's do it. So here's a R cross V. And we have I, J, K. And then we have 1, 2, -1, and we have 1, -1, 2. So that will turn out to be 3, -3, and -3. Did I do that right? Say yes. So if we take a magnitude of that thingy, that's gotta be 3√3, eh? Too much algebra? Yes, no, maybe. Okay, so what we have is 3√3 on top. And what's the magnitude of V? 1 plus 1 plus 4, right? Square root 6. And that's 3 over square root 2. Also known as 3√2/2, whichever you prefer. You don't have to rationalize the denominator anymore if it doesn't simplify. Good. Okay, moving on. This one. Now, distance between two planes. Shall we sketch the planes? I mean, abstractly. So I have one plane like that, and I have another plane like that. Good? Okay, which one is which? I'll go with consistent with the Dropbox note. This one is this thing, and this thing is 3x plus y minus 4z is equal to 24. And then one might think, well, isn't that distance from just like from here to here, so 22? No, it's not. Okay, it might be skewed, so no, it's like perpendicular distance is what we need, okay? See, I drew it like this, but what we might be thinking is, if you have a plane that is like that and like that, and this distance might be 22. But perpendicular distance is a lot shorter than that, as you can see, right? So no, I just drew it like this, but no. So that doesn't work. Well, we need any back vector, any point here, and we need any point here. Shall we get it? Okay, what is the nicest way to calculate this vector? Put 0 here, and then y is equal to 2, okay? So this point go to 0, because you know how I feel about formula, don't you there? And then this point, likewise, is 0, 24, 0. You with me? Say yes. Okay, now I'm going to create a vector connecting the two. So it looks like this. Let's call that, oh, I called it A, so I'll call it A. What is the vector A? That A? Say something. But that's some slanted distance. That cannot be the perpendicular distance. Perpendicular distance should look like this. If I have a normal vector, I'll just poking it through somewhere. You know what I'm saying? So this is a perpendicular distance, isn't it? We'll call that D. We'll call this angle theta. So my D here is A magnitude cosine theta, absolute value now, isn't it? Of course, as soon as you write it like that, then that reminds you of this. Right? And then you notice this is my N, normal vector. Somebody tell me what that normal vector is.
3, 1, negative 4.
3, 1, negative 4, right? Wait a minute. Do these things have why do they have same normal vector? Do you always have the same normal vector? The question is, are they always parallel? If they have the same normal vector, that means planes are parallel, right? Should it supposed to be always parallel? If the question is distance between two planes, they better be parallel, otherwise they intersect, right? Then that distance is 0. Intersecting distance between intersecting plane, that's 0 now, isn't it? So from the context of the problem, we realized, yeah, of course that's parallel. Okay, well then, let's dot them, right? So that product is easy, it's just the middle one, isn't it? That's just 22 over, okay, what's the magnitude of this vector? 9, 16, 25, 26. How about that? You get it?